Hi, algebra students. Please pull out your 4 powers of monomials notes template, and then you're going to try both the warm-up questions, the first one simplifying and the second one subtracting. My hint of the day is to make sure you pay close attention to that word from. That will affect your order, and you know order is important for a subtraction problem. So taking a look at the first warm-up question, we've got a simplify problem all with multiplication. Just a quick reminder that you are going to add the exponents when you multiply. Our coefficients give us -3 times 2 times -4 give us 24, and x squared plus x to the first plus x to the third give us x to the sixth, and our y's, y to the third, y squared, and y to the first give us y to the sixth. Looking over at the subtraction problem, I tried to show some work there because you need to first set it up in the correct order. You are going to start with the polynomial 5x squared plus 7xy plus 2y to the second power and subtract 2x squared minus y squared. And I tried to show my op sum there. I'm going to take the opposite of each of those and rewrite it as an addition problem, which makes it plus -2x squared. And then I didn't have a middle like term, so I just filled in a 0xy there, minus y squared, giving us 3x squared plus 7xy plus 3y squared. So today we're going to expand your knowledge of exponent rules beyond multiplying and dividing, which is what we looked at last week. To rewrite this problem here, x to the third raised to the fifth power, that's like saying x to the third times itself a total of 5 times. So I'm going to write that out on the first line. Now, following what you know from last week about multiplying the same base times each other, you are adding the exponents. So we're really taking an x to the 3 plus 3 plus 3 plus 3 plus 3 power, which is kind of obnoxious to say, so we would simplify that to be x to the 15th power. But then what I want you to notice before we even give you the rule here is we've got a 3 and a 5 and a 15. So seemingly, what happened to the exponents? We multiplied them. So jumping into our rule, the rule of exponents for power of a power is what you do is you take the base and you multiply the exponents together. So you're taking m to the n power here and filling in the blanks there. To find the power of a power, you multiply the exponents. So jumping into some examples here, we've got u to the fourth 5 times. And we're not going to ask you to write this all out on a quiz, but it's a good trick if you're unsure of the rule on the PSSA or the Keystone. You guys can write it out like that and then add your 4's together. So you would be really taking 4 plus 4 plus 4 plus 4 plus 4, and then that's going to give you a u to the 20th power, which is the same as multiplying these two exponents together. Looking over at example 3, I am taking what is actually a -1a squared. I'm going to add the exponent there, and I'm raising it to the third power. That means that both the coefficient -1 gets the third power and a squared gets the third power. So -1 to the third power is -1, and a squared to the third power is an a to the sixth power. So our final answer would be -1 a to the sixth power. Over here, the same thing. You're kind of distributing this power to each of these terms. So you've got a 2 to the third power, which is the coefficient, and x really to the first power. There's really a 1 there. And you're raising it to the third power. So we are doing a 1 to the third power, which is 8. 2 times 2 times 2 is 8. X to the third power. Now looking at another rule, if you're looking at the power of a product, we kind of just addressed that a little bit. What happens is you distribute the power to each of these bases, so each of them gets the power of m, so a to the m times b to the m, and that is going to be filling in the blanks there. To find a power of a product, you find the power of each factor, kind of the building blocks of a multiplication problem, and then you multiply. Looking at examples 5 and 6 out on the back, again, very similar. You're taking negative 2 to the 5th power times k to the 5th power. So negative 2 to the 5th power gives us negative 32. And I know it was going to be a negative because this is an odd exponent, k to the 5th. Over here, every single piece, including the coefficient negative 3, gets the power of 3. So negative 3 to the 3rd, x squared gets the 3rd power, y to the 5th gets the 3rd power, and then you're just going to multiply through. So negative 3 to the 3rd power gives me negative 27. You're going to multiply 2 times 3 to get 6, and multiply 5 times 3 to get 15. So that's our final answer there. And then last but not least, I don't want you to forget this scale. If we're going to evaluate k being 2, we are going to use 2 to substitute in here. So just like you did in pre-algebra, you've got your original line 1. Line 2, all you do is replace the t with 2. Now a good thing to know here is only the 2 has the exponent of 3. Otherwise it would look like this. And we're going to address that on the next example. So we've got 3 times 2 to the 3rd gives me 8, which gives me a product of 24. Over here for part B, each of these, this is a power of a product, each of these gets the power of 3. So we're doing 3 times 2 to the 3rd. But when you are evaluating, you can do, according to order of ops first, you can do 6 in parentheses to the 3rd, and 6 to the 3rd is 216. For part C, our plug-in's going to look like 3 to the 3rd times 2 to the 3rd. 3 to the 3rd gives me 27, and 2 to the 3rd gives me 8. And then we can multiply those, and that actually gives you 216 as well. So make sure you bring any questions to your math teacher about these two simple rules. This notes section was kind of short. Make sure you bring any questions to your teacher and that you're doing all the practice problems. Whatever you don't finish in class, remember to finish for homework so you get all that necessary practice.